So the weekly contest 354 just ended. I thought I'd just immediately make a video for it. So let's jump in. Sum of squares of special elements. So it's very actually confusingly worded, but what it's asking is pretty straightforward. It's saying for every index, if that index divides n, if it's divisible, if n is divisible by that index, then add the square of the element at that index to your total sum, and then return the sum of all of those elements. So it's a little confusing because it's referencing the index and the element, and then also the fact that it's one indexed is kind of odd, but it sort of makes sense, I guess, because you'd never have the 0th index if it was 0 indexed. But that's pretty much exactly what you do. You just go through and you say, if this thing holds, that depends on I plus 1 rather than I, then add x squared, and then return the result. This question was one of those questions that's harder than Q3. That's one of those Q2s. So it's saying you can increase or decrease any element by up to k in the array. You want to find the longest subsequence that is beautiful. And a beautiful subsequence is a subsequence where all the elements are equal, apparently. So to me, the really interesting part of this problem is to realize that the order doesn't matter. Like, for example, 1, the subsequence of, like, if the array is modified to be 4, 4, 1, 4, it doesn't really mean anything to swap those 4s around with each other. And the 1 is irrelevant because it's sort of deleted anyway to obtain that subsequence. And what that means is that what we can do is just immediately sort nums. And then the question becomes much simpler. Then all we need to do is just go through with 2 pointers, like a sliding window, and find the largest window where the smallest element and the largest element in that window don't differ by more than k times 2. This is how I like to set up my sliding window, L as an independent variable and R in the for loop. And then L plays catch up in this while loop, and then it's one of those things where once you get used to that sort of set of loop invariants, then it allows you to engage a lot more closely with the specifics, and you don't have to worry as much about like off by 1 errors or things like that. Yeah, and this problem even in my mind is a little bit deceiving, where it specifically goes out of its way to define a subsequence as different than a subset, even though specifically subsequences that have this quality are kind of the same as their corresponding subsets. It doesn't really, the order doesn't matter at all. And for that reason, I think this is kind of a Chinese finger trap question where probably the more Leetcodes you've grinded, the more you're tempted to just be like, hey, subsequence, so probably I'm not going to be sorting. But then in reality, this is one of those corner cases where you can sort it. So it's an interesting question. 6,000 isn't exactly the most difficult, but it's less than Q3. Q3 got 8,000. It's pretty straightforward. It's saying there's some value that's dominant, which means most of the elements in the array have that value. You want to find the earliest pivot point where if you split the array into 2 subarrays, that dominant value would still be the dominant value for both of those subarrays. So for example, you couldn't split here because if you split here, 1 and 2, 2 is not the dominant value. It's equal to 1 in frequency. But you could split here, which is the answer. This question struck me as extremely prone to off by 1 errors and things like that. So I was very explicit with it. First thing I do, I find the dominant element. I say, and the amount that is in the array in general. And then I say, okay, we'll just start from 0. So there's none of the dominant element before the array begins, and there's all of the dominant element after the array begins. And then we start out and we have, if I equals 0, a population of 1, just like how many elements at all are before equal to I, how many elements are greater than I. And then I go through. I mean, you could clean this up. The order is kind of wonky. Like this should probably be 0 and n, and then you move it, but it doesn't really matter. Speed is the priority here, so who cares? And then I just say like, hey, if we're at the dominant element, if nums at I is the dominant element, add 1 to L, subtract 1 from R. In general, add 1 to L pop, subtract 1 from R pop. And then if this quality holds, then we're good to go. If it's the dominant element in both subarrays, then just return I. And if that's never the case, return -1. So it's pretty straightforward. You're kind of just doing what they're asking, I guess. So Q4, it's a pretty simple question. It's just saying you're given a string and you're given a bunch of forbidden words. What's the longest substring that doesn't contain any of those forbidden words? We can immediately see it's about average for a Q4. I'd say it's almost exactly half of the Q4s get below 1,000 accepted submissions, and the other half get above. And the first thing to immediately notice as a really powerful tool, almost to the point of just being like an observation check. If you see it, then you're like, oh, wow, that's really peculiar. Why would they have that? Is forbidden at I.length is less than or equal to 10. Which means none of these words can be longer than 10 characters, which is huge. We could use like KMP, which is O of n squared, where n is the substring you're looking for, because you have to build an LCP array, a 2D array, least common prefix, longest common prefix. And O of n squared, if n is 10, who cares? And that's one example of many things you could do. I started to build that out, and then I didn't really like that, because, for example, in example 1, the longest substring is AABC, which includes a bunch of this forbidden word. Like AAA, we're getting rid of the first character, but then you could easily imagine a scenario where it's like BCAA, where you're getting rid of the last character, and it just seemed a little messy, and it seemed easier for me to just throw everything into a try. And that's exactly what I did. For people that use Python, this is an extremely simple way to declare a try. Or define a try. It's really basic. Default dict comes in super handy. And then that's what I do. So I say, okay, I build this try, which, to give a 50,000 foot view of a try, it's a tree where you represent a bunch of different words in a list of words, for example, forbidden, where you say the root is nothing. There can be up to 26 children of that. That's like the first character of a given word. 26 children for each of those nodes. That's like the second character, and so on. So when you put something into a try, you're just like navigating to the right node. And then for me, I just say node.val equals 1, which just means like there is a word here. This isn't a path to a further word. And then I make use of this dist array where I'm like, okay, for any given character, for any given index, what's the furthest we can travel from this spot before it becomes invalid, either because we reach the end of the string or because we suddenly encapsulate a forbidden word. And then all we have to do in the end is just return the maximum of dist. And then the question becomes, how do you fill this? And I mean, you just can go backwards. That seems like a pretty important revelation here, because then you can use dist at I plus 1 to inform dist at I. If you're looking at a given character, I'll even just type out a giant string down here. If you're looking at a given index, it's always at most going to be the next index plus 1, because it's going to be the length of this, and then you added d to it. And the only time it's not going to be exactly that is if there's some substring here that's invalid. And this is where forbidden at I.length is less than or equal to 10 comes in really handy, because it's like, well, wait, wouldn't you just be checking like a substring for every single index? And it's like, yeah, you would, but the substring only goes up to 10. It doesn't go to the end of the string. So in that situation, yeah, I mean, like, so for every character, you're checking 10 characters, but that's fine. That's like 10 times n, which is still just O of n. And that's exactly what you do. So you just go backwards. You say, okay, that looks good, whatever. Maybe you get here and you say, hey, GJKL is a forbidden word. So then GJK, dist at this index, is 3. And then you go here, you'd say H, hey, is this all good? Yeah. So now it's 4. It can't go past that, because then it's encapsulating a forbidden word. Yeah, that's pretty much what this code does. So it was an interesting contest. It was, I would call it, other than Q1, pretty satisfying. Hit like if this was helpful.